Hey guys, we're going through 1.2 and 1.3 today, and I'm going to use the textbook functions, model and change, a preparation for calculus, the 4th edition. So first for 1.2, we're taking at the look of rate of change. So let's see what rate of change is. Basically, so the average rate of change, or we just call it the rate of change of q with respect to t over an interval would be change in q over change in t, which we just put as delta q over delta t. So what that means is, let's say like we have something here. So the change in time where the change in sales is made, that would be the rate of change. So over the time you sell the CDs or the DVDs, you're going to put the change in sales. So that would be your rate of change. Excuse the sound in the background, you can just ignore that. Okay, moving on, we're going to take a look then at increasing and decreasing functions. This is kind of straightforward actually. So basically on the time interval, so if q is ft as a function, if f is going to increase, that's going to be obviously an increasing function, and if it's decreasing, it's going to be a decreasing function. So if you take a look here, if we have a graph something like this, we see that as time goes on, like if the radius, let's say it increases, the area increases as well, and this is basically what they mean as an increasing function. Whereas t increases, f will increase as well. But if it was something like this, then it would be a decreasing function, because as t increases, f will decrease. So that's basically what they're saying. And if f is an increasing function, then the average rate of change with respect to t is positive on every interval. That would definitely be true, because if we subtract this part, it would definitely be positive. But if it was decreasing, you're doing it from points like this, so it would definitely be negative. Okay. And if I just shortly talk about how the graphs will look, so if the graph of an increasing function is going to rise when read from the left to right, and for a decreasing function, it's going to be the opposite. So this is what you can see, as this is an increasing function, whereas this is a decreasing function. So it's very simple. Another thing we can look at is the average rate of change over a certain interval, like this, where t is the same or bigger than a, but smaller or the same as b. So this is, well, we know this because we said that the average rate of change, or the rate of change, is delta q over delta t, but that's going to change like this because we have a certain interval that's given, something like this. We're not looking for the whole thing, but just a certain interval from a to b. So we're going to do fb minus fa, and the change of time would be from b minus a. Okay, now quickly we're going to take a look at linear functions. Linear functions are actually quite straightforward as well. So if we take a look at how the graph looks, well, this is a linear function. It's linear, it's straight, exactly what it means. A linear function has a constant rate of change. That would be definitely true because it's increasing at a constant rate, so it definitely will have a constant rate of change for the time interval that it takes for it to increase or decrease. So the graph of any linear function is a straight line. Of course that's true because linear means straight. We looked at increasing linear functions, and this would be what a decreasing linear function would look like. It's a straight line, it has a constant rate of change, all the same stuff, everything you know. And then moving on, when we have y equals fx as a linear function and they have constants of b and n, the slope is going to be delta y over delta x, like any slope you would find. And then the two distinct points from f would be something like this, and then the slope would be from here. This is basically like looking for a certain time interval. And b is called the vertical intercept or the y-intercept, of course, because we learned from middle school, junior high, that this is the y-intercept, and if it's constant, it will be what it's meant to be. Okay, so that was the end of 1.2 to 1.3. I hope that was helpful for you, and I will see you in our next video.